All right, we've got an interface board here to work with the Hopper program. Uh, we're going to be using a PLC to control it. Because we're using a different power source again to actually control our devices, I need to have some relays, which I have here. The sequence that we're looking for was we want to energize a Hopper only if a motor is up to speed. So in our process, we'll have our stop, start, etc., and we're going to have our inputs and outputs monitor on this terminal connections and our 24 volt to supply the motor and the solenoid. So if I have now we'll point out a couple of things. If you energize the motor, this is a speed control. DC motors, normally you can control them by controlling the amount of current. And in order to control the current, you need to have a parallel circuit to either add or subtract through obviously using the reciprocal of reciprocals method. So if you wanted to have a very slow speed, then you have one resistor, and if you add another resistor in parallel, then the current's going to go up, the motor will speed up, and if you add another one in parallel, it's going to do the same thing. Or you can use a speed controller, and this one uses pulse width modulations to create a DC signal, and we can adjust the speed using this. If you don't, it will draw a lot of battery power. These are 27 volts DC power, and this will drop that. This won't take a lot, but it will maintain it, and it has a spring return, so it will actually draw quite a bit as well. So what I'm going to do is show you that I can control the two relays. So you can see that the solenoid moved, and you can see that the relay came on. And I can also control the motor. Now if I follow the order correctly, I'm supposed to start the motor first, let it run for a bit, and then open up the hopper. And you can see that there's quite a bit of drop, because there's quite a bit of load for a 20 certain unregulated power supply. We can slow the motor down even more, or speed it up. The faster it goes relative to this, you are going to wear out batteries quickly. So the first thing that needs to happen is we want the hopper to open up and then let the motor run for a bit to clear the conveyor, and then shut the motor off. And that's pretty much it. So these are our connection points. We have two outputs, we have two inputs. We're using some feedback via these relays. And to confirm that we've actually told the solenoid to move, we told the motor to move. We don't have a proximity switch or a limit switch on any description on our solenoid, and we don't have any confirmation from our motor that we're actually turning. So this, we could, in theory, come up with a method to use that same signal that we're sending the motor to trip a relay confirming that signal has been sent to the motor to turn, but we don't have enough inputs and outputs, and we cannot take that signal directly to the PLC. It would be considered an analog signal if we're actually going to start messing around with the speed. So for the first sequencing lab that we're going to be working on, you're going to be using it for the Hopper conveyor system. When you've written your program, I've got 4 of these built. We'll come by, I have the cable connections, we'll connect up your PLC, and you'll run your program and demonstrate that it actually works the correct sequence in the correct order.